All right, welcome to your first day of virtual for the school year. I'm going to run through the notes with you. I'll go through some examples. You're going to want that note sheet that I gave you with the formulas on it. Um, and when I go through the notes, I show a lot more work than maybe you would expect to see. So if you can find some shortcuts along the way, that's fine with me as long as you're doing your math. Otherwise, on your notes, I kind of highly recommend that you show your steps so you have something to look back at. That's sort of the whole point of it. So our first part of our problem is, or part of our notes is going to be to review the distance formula. And the formula is, um, if I can get my marker to work, let's see. Oh, there we go. Okay. So the formula is the square root of um, x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And I'm afraid to get rid of this piece here because last time I tried to do that I couldn't get the marker back, but we'll see. Hopefully this works. Um, so there, oh, not so bad. Okay, so there's our distance formula. Keep in mind that these little things right here are subscripts, and that just means that I'm looking at a first point, so this could be called x1, y1, and a second point, x2, y2. But keep in mind that you could flip-flop these. I could call this first one x2, y2 if I'm feeling crazy, and this second one, this second point here, the negative 1810, I call that x1, y1 if I wanted to. But I'm just going to keep it like this and just follow the formula as is. I'm just going to keep it real basic, okay? So I'll plug it in the square root of, this is negative 18 minus 3 quantity squared plus 10 minus 25 quantity squared. Then I'm going to go ahead and do the math. Negative 21 squared plus negative 15 squared. Keep in mind when you have a negative squared, it's going to come out positive no matter what. So be careful of your calculator. If you don't plug the thing in parentheses, you're going to end up with a negative answer on some of the calculators. You should end up with 441 plus 225. And then when you do your simplifying, you'll get 666. And so now when you stop there with your answer, sometimes that's going to be a fine enough answer, but sometimes we're going to need to break it down and simplify it. Simplest radical form is what we call it. So I'm going to go with simplest radical form. There are, again, a lot of different ways that you can do this. This is the way that I would do it. Especially if I'm just going kind of through the basic steps. I just do repeated division. 666, it can be divided by 2. I start with the smallest number that goes in there. That's 333. 333 can be divided by 3. That's 111. 111 can be divided by 3. I keep going smallest that I can. 2 doesn't go into 333. 3 does. 3 goes into 111, and that is 37 times. And so what I have here is the square root of 2 times 3 times 3 times 37. Well, for every pair I see in, I take 1 out. And so I'm left with 3 times the square root of 2 times 37, or 3 times the square root of, what is that, 74. And so then this would be my final answer for that problem. Now, I just wanted to review that process with you. We don't always have to do this, especially when we're working with circles. We don't always have to break it down into simplest radical form, especially when we're working with circles, because we're going to end up squaring the radius and we're going to use it to find the radius. But if I'm just doing the distance formula, I'm going to want to make sure that I break it down if possible. So I'm going to go through that process again. This is x1, y1, x2, y2. And I'll go ahead and put it in the distance formula. So I have negative 12 minus negative 4 quantity squared plus 0 minus 13 quantity squared. Do the square root of that. That's negative, negative 8. I almost made an error there, squared, because plus positive. So that'd be negative 12 plus 4, so negative 8 quantity squared plus negative 13 quantity squared, and then I can go ahead and square those negatives. They become positive. Don't forget that. A lot of people make a mistake on that. And when I do my final addition here. I have 64 plus 169, so that is 3, 13, 12, 13 again, and it looks like 233. Now, try as you might, you can divide by 2, divide by 3, divide by 4, divide by 5, keep going through and seeing what you can do, and there's nothing that goes in. There are numbers that go in here, but nothing that goes into here where I'm going to be able to find a pair like I did on that last one. And so this one can stop in this form. So that's the review of the distance formula. We're going to move on to plugging into the equation of a circle. And again, there are different approaches, and you might have one approach that you learned from a teacher in your past, but the basic layout for a circle is x minus h quantity squared plus y minus k quantity squared equals the radius squared, where h, k is the center and r is the radius. And so I'm going to go through, and sometimes it's as easy as this. Here's h, here's k, here's r. I just have to plug it into my formula. This is x minus 9 quantity squared plus y minus negative 13 or plus 13 quantity squared equals 3 squared r squared or 9. Remember, when you plug it into the formula here, you're going to be doing this. It is squared, so I'm going to have to square that number when I plug it in. But then this is, when all is said and done, your final answer in that form. I'd love to say that they're all going to be that easy, but of course not. You know, there's going to be instances where you're going to have a little bit more work involved. Like, for example, on our next problem, we have, oops, did I accidentally go to the next page? No, I must have. What happened? All right, lost my page for a moment. I don't know how I deleted that, but I did it. It's gonna take me a while to get used to this smartboard. But anyways, as I was saying, sometimes we're going to end up with having to do a little bit of work. And so in this case, I have the center, and then I have a point on the circle. And so I'm going to have to find the radius. I have my h and k, but the radius is the unknown. And this is where the distance formula comes into play, because if you think about it, if I draw a circle, my center is 13, negative 5. And my radius goes out to a point on the circle. That point is 16, 0. So my radius is going to be the distance between those 2 points. So I'll set up to find my radius by using the distance formula, where I have my x1, y1, x2, y2, and then I can go ahead and do the distance formula that I did before. So this is 16 minus 3 quantity squared plus 0 minus negative 5 quantity squared. I'll end up with 13 squared plus 5 squared, or 169 plus 25, or a radius of the square root of what is it, 194, I believe. Again, you can check my math. Sorry if I made a mistake. Holler at me tomorrow if I did. But 194, it looks like it is. And so now I have my radius, but keep in mind, I'm going to have to square the radius when I put it in. So I don't need to break this down because I'm going to square the radius. So when I square that, I get 194. And so I can just plug it into my formula. This is x minus h quantity squared plus y minus k quantity squared, remember minus a negative becomes positive, equals 194, which is the radius squared. And so there is my, again, final answer on that one. I'll run through the next one, and then we're going to try a couple other different things. So this is a very similar problem. In fact, if you want to pause the video right now, I'm going to do the same thing. See if you can go through that problem, and then when you're done, we can put it all together. So I did go through and work that problem out Hopefully you did the same. I got r to be the square root of 61. I got r squared to then to be 61. So I can just finish off my circle. This is x minus 9 quantity squared plus y minus 0 quantity squared equals r squared 61. I've also seen people write this as x minus 9 quantity squared plus y squared equals 61, and that's because, of course, y minus 0 can just be rewritten as just y. So moving on, we're going to check somewhere we have to find the, where we're given the diameter. And again, I think it's a little helpful to draw a picture. So I'm going to go ahead and draw my circle, but keep in mind we have here end points of the circle, ends of a diameter. And so this is just sort of a little drawing as a placeholder to fill stuff in. So don't worry about like putting it on an actual grid. It's not like I'm thinking about where things are. I'm just sort of thinking about these problems in terms of, or the circle in terms of something to hold the picture or the information that I have. Okay, so it doesn't have to be perfect, it doesn't have to be beautiful, but I need to find the center. And my center is smack dab between the two endpoints in the diameter, and therefore I'm going to use the midpoint formula. So the midpoint formula will be the average of the x's and the average of the y's. So when I'm doing the midpoint formula, it's on your formula sheet. It is x plus x divided by 2, comma, y plus y divided by 2. Please make sure that if you're using your calculator, you hit equals before you divide by 2, otherwise it won't give you the point properly. But my midpoint, or my center, I can call that, midpoint formula will give me my center. The center is going to be negative 1/2, and that would be what, negative 32 halves, so negative 16. Now, next thing I need to do is find my radius, and there are two different approaches for this. My radius can be found by finding one end point to the center, finding the other end point to the center, or the other thing I could do is I could find the diameter and cut it in half, because the radius, remember, is half of the diameter. Now, how do I decide when I'm going to do one or the other? Well, because this one here has this fraction in it, I might want to go ahead and use the diameter and cut it in half so I don't have to do the math with the fractions. And so that's what I'm choosing to use. So I'm going to find my diameter, which is the distance between the two end points. So here's x1, y1, x2, y2. And again, I'll go ahead and plug that in. That's 1 minus negative 2 squared plus negative 19. That's a 19, negative 19 minus negative 13 squared. So I have 3 squared plus positive. Plus, remember that was a negative 19, sorry for my scribbles, negative 19 plus positive, so that's negative 6 squared. I end up with the square root of 9 plus 36, or the square root of 45. Well, now remember that's the diameter. I want to erase that. I think I don't like. That's the diameter, and I want the radius. So the radius is half of that. So don't overthink it. I'm just going to go ahead and take the square root of 45 and cut it in half. So I stick a 2 underneath it. But again, remember, the radius is not what I'm using. I'm using r squared in the formula, so I have to square this whole thing. So r squared is the square root of 45 over 2 squared, which is square the top, 45. When you square a radical, it removes the radical, and then square the bottom, 4. So that becomes my radius squared. That's the part that I'm going to use in my final equation. So my circle formula is x minus negative 1/2 quantity squared plus y minus negative 16 quantity squared equals r squared 45/4. And so there's a couple things that I had to worry about there, and that was finding the diameter, remembering to cut it in half, and not forgetting to square it. So as you see, as we go a little bit further, the problems can get a little bit more difficult. Just sort of take your time. So again, I'm going to pause the video, and I'm going to have you give the next one a try, and then see how you do. Keep in mind, there are other approaches, so the end result is what I'm looking for. You can do it however it works best for you. And again, so again, our goal is to end up with the same result. However you did it, I did this one the same way I did the last one, just so you could check and see. If you chose to find the radius instead and work with it, you should end up with the same thing. But I found the diameter, got that to be the square root of 128, cut it in half, got that to be the square root of 128 over 2, squared that. I was able to reduce it. So my final answer is x minus 6 quantity squared plus y minus 13 quantity squared equals 32. All right, we're down to the last couple on the notes, and the last couple look more difficult than they are. Again, we're given different information, and this uses yet again one of the formulas that's on your sheet of paper. And one of the formulas that you have is that the circumference is equal to 2 pi times the radius. And so what I need in this problem, I've got the center, I need the radius. The radius is the unknown, but they give me the circumference. So circumference I'm using as c. If the circumference is 4 pi, that means 4 pi is equal to 2 pi r. Well, I can just do a little algebra, divide the 2 pi out. 4 pi divided by 2 pi is 2. That means my radius is 2. And so I have the center, x minus negative 4 quantity squared plus y minus negative 15 quantity squared gives me r squared. Don't forget that I have to square it. I've got to get r squared. And so my answer there is 4. Sometimes the problems look a little bit more complicated, and please try not to overthink it too much. It still is, my circumference is 2 pi times the square root of 37, and the formula is 2 pi times the radius. Well, look at this. I get rid of the 2 pi, I get rid of the 2 pi, cancel out. That means the square root of 37 is my radius. That means 37 is my radius squared, because that's what I need for my formula. So I get x minus negative 10 quantity squared plus y minus 0 quantity squared equals r squared 37. So I could rewrite that again as just y squared equals 37 in simplest form. And so that's distance formula, circles. We dealt with midpoint. And so what your job today for homework is to just do section 1.1. So it's 1.1 in your homework packet that I gave you yesterday. That's okay. Do evens or odds, whichever you prefer. It doesn't matter to me. And then come tomorrow with questions. Or, of course, you can always email me as well. So good luck. I hope all goes well, and I will see you tomorrow.